Had a nice week and are ready for our third class of Java Level 1. So just jumping straight into things, a little bit of a review for today. We're going to go over the homework from last week, which was talking about the last kind of loop, the enhanced for loop or the for each loop, as well as the break and continue statements. We might go over some review questions about that, and then we're going to move on from loops to a new topic called methods. And that's going to be the focus for the rest of today's class. So I'm going to get started. Today, I'm going to start screening my screen. So today, I think it's loading. All right, it's finally loaded. I want to go over the homework, but I want to do so in a way where I'll call on some people to help build up the solution piece by piece. We'll see that the final answer is not that long, so it shouldn't be too bad. But just a reminder of what the assignment was. I guess I can go over to Google Classroom. So this was the instructions. Essentially, you have an array of numbers that you need to process, and I wanted you to loop through them and follow some of these rules. So for example, if you're going across these numbers and the one that you're looking at is even, basically just ignore it, skip it, and move on to the next number. If the number is exactly 99, the special value, then I just want you to stop. Don't process anything else. Otherwise, if it doesn't follow those first two rules, then just print out the value. And so I had like a sample input and sample output. So what I have right now in my Eclipse is basically just the input. So this is what I had in Classroom, and I put it inside of an integer array and called it nums. So the first thing that we need to do is basically write a loop that goes through this array. So here's the first question. Can anyone help me write specifically a for each loop that will go through this array? So really, I'm just looking for what goes in here, right? Because you know it's a for loop. So we have the for, and we have the parentheses, and the body we're going to ignore for now. But can anyone help me? What should I put here if I want to loop through this array, nums? Okay, I see a chat. All right. Thank you, Sophia. So you said int I and then a colon and then nums. Right? So, but int I colon nums. And that's exactly right. So a review, this is the for each loop that we learned from last week. And the way it works is a little bit different from the other for loop that we learned first. There's only kind of one thing inside the parentheses. There's no semicolons. And instead, we have basically the array or the collection that we're looping through. So here we're looping through nums. And then we have a colon and we have a variable declaration. And so some things that you need to make sure that match are that the type of this variable is the same as the type of the array, right? Because this variable is basically going to take on every value one by one. So first I is 1, then it's 2, then 3, 4, 5, 24, 42, so on, so on, so on, right? So that's why the types need to match, right? Because if you declare this as like a Boolean, well, if this variable is a Boolean, well, we can't assign like 5 to a Boolean value, right? 5 is an integer, so we need to assign it to an integer variable. So that's why we have this part here. And so now, let's pull up the instructions again. So here it says, let's just do the rules one by one. The first one is if the number is even, aka divisible by 2, skip this element. So let me try to pull it up side by side so we can have the code and the instructions on at the same time. Oops. cancel. So hopefully the first line of code is cut off a little bit, but hopefully it doesn't matter too much. But maybe someone else, can you help me write something that will handle this first case? If the number is even, skip this element. What would that look like in our code? How about, okay, I see a message. Evan said maybe use the mod, the percent sign, which means mod. That's a great idea. I like that. So that, Evan, can you tell me why that might be useful? Like what part of this first case would that percent thing be useful for? I do agree we probably should be using it. Um, yep. So the percent sign, if you don't remember, stands for modulus. It basically says take two values, divide them by each other, and what is the remainder? And so it's useful to check if things are divisible or not. Because if things are divisible, then the remainder will be zero. So we will want like an if statement. And here we want to check if our number is even. So remember in our for each loop, I is what's going to be every value in our array, right? So I is what we want to work with inside the loop. So we want to basically just say, is I, if I divide it by 2, what is the remainder, right? If the remainder is 0, that means it's divisible by 2, right? And again, divisible by 2, even, same thing. So here, I'm looking at the remainder. I'm checking if it's 0. If it is, so if it's true, then here, I is even. Is that clear to anyone? Does anyone have any questions about this if statement that I've written right here? What the percent sign means, why we do this? Cool. So kind of the last missing piece of the puzzle is that what goes inside the if statement. So it's going to be just a single word and a semicolon. So maybe, let's see, Eddie, do you think you know what we should put inside the if statement? Um, we know that if we're inside the if statement, this variable I is even. And we said if the number is even, we want to skip this. We don't want to do anything else. We just want to move on to the next thing in our array. So how do we do that? How can we skip part of the loop? Do you remember, Eddie? Break. Very, very close. So break will skip part of the loop, but it'll skip everything. So break means exit the loop immediately. We don't want to exit the loop uh, completely. We just want to exit part of it. And so that's why we want, and I see in the chat, continue. Yeah. So thank you, Ethan and Jerry. Great job. Yeah, we want continue. And I see that, oh, that's great. Yeah, so the difference between break and continue again, continue is skips less than break. So you can think of break as like a hard thing. It's very strict. It skips everything, right? Continue is a little bit nicer. Like it only skips one iteration of the loop, right? So the loop will keep going. It just skips whatever it's doing right now. So we say continue. And so if we look at the instructions, the second one is where we want to use break, right? So the second one says if the number is exactly 99, we want to stop and don't process anything else. We're done. And so this means that we want to use break. Yeah. So I'll write it like else if. I'll use an else if structure. Else if I is 99, no problem, Eddie. So if it's 99, then we break. And the last case, it says just print out the number. So hopefully if we're comfortable with that, so system.out.println and then I. So let me just full screen the code now. And if we run this, let me run it. Oh, I'm running the wrong thing. Let me make sure I'm running this file. There we go. So hopefully it matches up 135, 51, 83, 97. Yep. So this is the output that we were expecting. And we notice that, I'm just trying to make the code a little bit larger. So hopefully this made some sense. This is just a practice to use the for each loop. You didn't have to use the for each loop, but it's a little bit simpler in this case because, again, what's the difference between a normal for loop and a for each loop when you're going through an array? Well, for a for each loop, we don't have to worry about keeping track of indices. We don't have like a variable that's an index and then use that to access our array. And the for each loop does that for us automatically. It automatically takes every single value in our array and assigns it to I one by one. Right? We don't have to manually go into the array and get a value out of it. It's basically just a little bit less typing on our end, but it's nice. And then also practice between continue and break. Another way to think about it, continue versus break. Continue, you can imagine when you're running the code and you hit a continue statement, you will jump just above the end bracket for the loop, right? So this is the loop. It starts here, ends here. So when you hit a continue, you jump right here, right? You basically jump here and you immediately go to the top again, right? So that's what it means by skipping an iteration and goes on to the next one. Break, on the other hand, jumps a little bit farther. I'll say jumps instead of goes. Maybe a little bit less confusing. So when you hit a break statement, what happens is you jump to the end of the loop, and if there's any other code afterwards, it'd run that, right? So kind of the difference, another way of thinking about it is whether you jump before the closing bracket or after. Continue goes before it, break goes after it. So one follow-up to this that I want to ask is if we think about like reordering these statements, right? So let me ask, if we take this code and we exchange the first and second cases. So I'm gonna move the first case up, and this is a little bit weird. I think all the brackets are balanced. Yeah, so I swapped the first and the second case. So now I'm checking if I is 99 first, and then checking if I is even afterwards. So let me ask, do we think that this will do the same thing? Will it still work, or will something be wrong? Because sometimes when you swap cases, it matters, sometimes it doesn't. So I want to see, what do we think for here? Do we think it matters if we swap these two cases? Sophia says, I think you still work. Does anyone else want to agree or disagree? Angela agrees. Eddie agrees. Okay, good. Yeah, so this should still do the same thing. And just to confirm, we can run it and we should see that the output, yep, is the same thing. And so kind of the reason for this is, well, there's two things. One is because the two cases are independent of each other, right? 99 is an odd number, so you'll never be both even and 99. So you'll only ever go to one, so it's not like the order matters there. But there's another thing that's important, and let me try one other thing. So we saw swapping those didn't really change anything. What if I swap, um, well, it's a little bit hard. Um, if like I swap the third and the second case, I'd have to do this a little bit differently. So here, essentially notice what I'm doing is I'm only printing out the odd values because the even ones I continue. So if I change this to not equals 0, and I put the print statement here, and I put the continue in the else, I'll say odd now. Is this gonna do the same thing as before? Or is this going to do something different? Well, actually, it's so actually, if we run this, we're gonna see it's still the same. So it's kind of a trick. I might have tricked you. Um, so it's only the same because I did change the case. I did change this from equals equals to not equals. But um, even if this works, it's being a little bit funky because this continue is kind of being a little bit weird. Because if you think about it, it's not really doing anything. Because whether you continue or not, you're going to end the loop anyways. There's nothing to skip. So the continue is not doing anything special. This would work exactly the same if we commented this out, actually. Um, and maybe one case where finally we would get a different behavior is now if we swap the first and second case, now we would get something different. Um, let's do that, actually. X paste X paste spec. This, I'll ask one last question. This will do something different. Now my question is, what will be different in this case? So this is the output before I made the change. I claim that if I run this, I will get a slightly different output. Yeah, so both of you guys are correct. It will print 99 and it will actually print out everything else afterwards as well. So if we run this, you'll see that we have what we had before, but then notice it keeps on running afterwards. And this is actually more of the fact of the if statement. So The reason why now swapping does affect things is because our two cases overlap, right? I is 99 and I is odd overlap with each other because 99 both is odd and is 99, right? And so what happens is when we when we do everything beforehand, it's all the same, right? But once we hit this 99, something different happens. We check our statements in order. So we check our first statement and we say, hey, 99 is odd. So we print it out. And then remember for an if else structure, if we go in one of the cases, we skip the rest. We don't care about them. And so it'll jump here and move on to the rest of the array, right? It never will reach this place where it breaks. Right? Is that clear? Hopefully. Really, this is showing that you need to be a little bit careful with your breaks, your continues, and especially if they're like in if statements. Swapping things around sometimes can affect things. But I'm really happy with the participation in chat so far today. All right. So I think that's all I had planned for the homework review. Just I just want to take 1 minute, see if anyone has any questions in general with the homework or the things that we did last class with the for each loop and break and continue. All right, I don't see any questions in chat. But if anything comes up, feel free to just drop it in there and I'll see it and we can talk about it. In the slide deck from last week, which was posted to Classroom, if you noticed, there were a couple slides at the end with like quizzes. Um, I won't go over all of them, but they're good practice if you want to try it out. I want to go over just one of them, which I think is kind of interesting. The others are more typical, just can you figure out what these loops will do? You can check them if you type it out on Eclipse and run it for yourself. But this one I want to talk about, and this will be our last review question. But we can take a moment and read it, and we'll see what's wrong. So the question says, we have a for loop in this section, and we want to kind of convert it from a for loop to a while loop. And we want to do it like, make sure it does the same thing. However, there's a bit of a problem. And the question is saying, what is it? So if we look at the code, just look at part A. Notice we create a sum variable, and then we have a for loop that goes from 0, less than 4, and plus plus. Here, this check is similar to what we saw in the homework. Here, we're checking if it's divisible by 3. If it's divisible by 3, we continue. Otherwise, we add the I to our sum. So what this is going to do is I is 0. Well, 0% 3 is going to be 0, so we continue. Then I is 1. 1% 3 is 1. We don't continue. We add it to the sum, so we add 1. Then we go to I is 2. 2% 3, 2 mod 3 is not 0, so we don't continue. We add it to our sum. Our sum went from 1 to 3. I is 3. 3 mod 3 is 0 because 3 is divisible by 3. So we skip it. Then I is 4 and our loop stops. Right. So here sum will become 3 at the end. If we look at the while loop, there's something that's a little bit off. we have mostly the same stuff. The only difference is that, well, instead of this for loop, instead of creating the I in the loop, we create I outside. We have the same condition and we have the same increment. We even have the same if statement and the same sum plus equals I. But there's a very like critical error with this. Can anyone tell me what that is? You need to put that plus plus in front of the continue for the while loop. All right, I like that. Can you? All right, yeah, yep, yep. So I think we have the reason. Yep, I agree. So we the problem is with the continue and the I plus plus. Um, you have to be a little bit careful here because remember, continue skips everything in the loop, and if we continue, we're gonna skip the increment. So in this case, I doesn't change, and then that means we're going to loop again with the same value of I. We're going to continue again. Nothing's going to change. We're going to go forever. So the second loop is actually going to be an infinite loop. So thank you, Sophia and Angela. Both of you are correct. To fix this, technically, if you put the plus plus first, it would fix things. But in general, that would also be slightly incorrect because if you think about how that would work, then the plus plus, like the first time the loop runs, in this loop, I would be one, right? Because I starts at 0. If the first thing that we do is plus plus, then everything here, I is 1, which is slightly not right because we do want it to start at 0. So there's a couple ways you could do it. You could add a plus plus in the if statement. So instead of just continue, inside this if statement, you do I plus plus and then continue. So you'd have it the plus plus in 2 locations. So it'd always do that. That might be the simplest way of fixing this problem. But yeah, I'm glad you guys caught on. So that's it for loops. I know we spent a long time on this, but I think loops are a very important part of Java and just programming in general. All languages have their versions of loops. You're going to use them a ton for sure. It really helps compact your code so that you don't have to repeat blocks over and over again. You can just write it once and then run it multiple times in a loop. But that idea of not repeating yourself actually brings us to the new topic for today, which is methods. So we already did a lot of review. So moving on, methods is a way of taking a block of code and kind of packaging it together. Once you do that, you can now run that block of code in multiple areas very easily. So you write your code once, you put it inside some sort of box, and then later on you can just say, oh, hey, remember that thing in the box? Do that, right? Reference that. Go there, look at what's in the box, run that code, and then come back to me, right? And that way you have your logic in one place, and you can reference it multiple times. A method is sometimes also called a function, and I will be using those words pretty much interchangeably. So method, function is the same thing. And if you took a Python class, you might have heard these terms, and it's basically the same idea. We're just going to see how to do it in Java. Methods also take in things called parameters, and this is kind of the input to your method. Yeah. With the name function, you can, if you're familiar with like a math functions take in an input and typically give you an output. We're going to see in Java functions, methods, some have an output, some functions do not have an output. They just don't return anything. So method, we're going to see the different components of it and how to declare your own method. And actually, we're just gonna go straight into Eclipse, I think. So a quick note is that if we look at Eclipse and let's just look at our homework, we actually see a bunch of examples of methods. So for example, this system.out.println, this is a method, right? This is a function. You might not have realized it before, but it should make sense. Basically, someone wrote the code that allows you to print things to the console. They wrote that somewhere else, and all we're doing here is we're referencing it. We're using it. We're using code that someone else wrote, and it's very useful because now we don't have to figure out how to like pass data from our program to the screen over here, right? Someone had to do that, but we didn't have to. We can just use it, and it's very useful. So this is what it looks like when you're calling a function, right? This is basically the function, and then here I is the parameter. We're passing in I as data for the function to work. And in this case, there is no return value. It does something, but it doesn't return a result, right? So this is an example of us using a function. But here is an example of defining a function or a method. So this, we're gonna start to understand what this line means. Maybe, I'm not sure if you guys already know, maybe every time you see this, you're just like, okay, this is something I see in all my Java files. But this is something called the main method, and it's very important. It's called the main method because the name of it is main, and that's it should be. And this is the name of the method. Afterwards, we have a set of parentheses, and then inside the parentheses are our parameters. What does this method take in? Here, we notice it takes in a string array called args. And then we have some stuff in front of it. And this is, we'll talk about what void means, but public and static, this will come at a later time. So this, you're gonna have to wait on a little bit more to understand fully what public and static means. But in today's class, we're gonna really understand what the rest of this all does. Okay. So this might still be a little bit confusing, but here's like a diagram. So here is all the components of a method kind of color coded for you. Well, not exactly color coded, they're all the same color, but at least highlighted. So as we mentioned, in this case, this is the method name. It's the thing right before the parentheses. So here, our method is called max. And then we have our parentheses, and inside is what's called the parameter list. So with our main method, we had a parameter list that only had one parameter. But in general, you can have multiple parameters. You can have multiple inputs to your method. And so in this example, we have two inputs, an int x and an int y. Right? And then going backwards, the thing before the method name is called the return type. And this is what we define, what does our method return? So in this case, our method returns an integer type, int. For methods that don't return anything, that's allowed, we have the void type. So that's why we have void here. Void is just a special term that we have in Java. It just means that there is no return value, right? Once you use main, you don't get anything back out of it. But in this case, this max function, when you use the max function, you will get an integer out of it. And you might guess, if you look at this body, the return x, return y is new, but you might be able to guess that this function, when you run it, you pass in two values, two integers, and it will just give you whichever one is larger. Right, so this is actually a valid Java method, and we could paste this into Eclipse and we could use it But yeah. So that's the method structure. So I want to take a moment. Does anyone have any questions so far about these components? I glossed over the first one, which is labeled the modifier. We're going to talk about this more in later classes. For now, we're going to see all our methods are going to have the same modifier. But really, does the return type, method name, and parameter list, do we have any questions about those? So again, if we like compare this with our main method over here, public static, that's the thing that we're gonna gloss over for now. This is the modifier. And then we have the return type, which is void. We have the name, in this case it's main, and then we have our parameter list in the parentheses. And here we take in a string array and we call that args. Right. Just some rules. As a convention, methods in Java, you start them with a lowercase letter, but if it's like multiple words, you can't have spaces, but to separate our words, we just capitalize the first letter of every other word. So if we like wanted to call this function instead of max, we wanted to call it get max, we would typically write it with a lowercase g and then a capital max. So I put it in chat. It would look something like that. That would be the typical convention of naming our methods. This is not a requirement. Nothing enforces this. You can call your methods whatever you want, but this is what I'm gonna do. This is what most people follow. So it's just a standard, and it's good to follow it. Yeah. There's a note though. Basically, anything that can be a variable name can be a method name, and the opposite also applies. So if like we know that you can't name our variables like numbers, like we can't start a variable name with a number. We also can't write a method name that starts with a number. Also, some special symbols are not allowed in our method names. So that's just a minor detail. Uh, Next up is just a term I want to define called the method signature. And we're going to see why this is important later on. But really, a method signature is just a term that means the method name and the parameter list. So if we look at this function right here, the method signature is going to be max with the parentheses int x int y. So it's the combination of the method name and the parameter list. And I also type that into chat. So that's the method signature. The reason why we define this special term is two methods cannot have the same signature. That's not allowed. And just by calling a signature, that might make sense. Like in a real world, your signature should be something that's unique to you, right? No two people should have the same handwriting signature, right? Same thing applies in programming. You shouldn't have two methods that have the same signature. The reason, you can't differentiate the two methods anymore. If you have two methods that have the same signature, you don't know which one you're supposed to use. And so to fix this problem, Java just says you can't define two functions, two methods that have the same signature. Importantly, the return type is not part of it, and also the modifiers. That's not part of the signature. It's just the name and the parameter list. There's some more stuff here, but I want to jump to writing some methods in Eclipse. So we'll go back to the slides later. So let's look at some example methods. So here I have a new Java class that I can write some code in. So I'm going to create some really simple methods right now. The first one I'm going to do is a method called add. So for now, all of our methods are going to start with these two words, public static. Again, I won't go into why we do that right now, but we will see why by the end of Java level 2. So just have to wait probably 2 weeks until we get to why. So we always start with public static. Then we have to think a little bit. I want to create a method called add. It's going to take two numbers, add them together, and give me the result back. Right? And so the first thing that we have to write is return value. I'm just going to say my function is always going to work with integer values. So we're going to take two integer values, we're going to add them together, we're going to get an integer value in return. So I'm just going to say int for the return type. Then the method name, I'm going to call add, and remember, by convention, it's lowercase. Then we have our parameter list. And as I mentioned before, this method takes in two integer values. So I'm going to call that int x and int y. Sorry. And then we have curly braces for the body of our method. And you'll notice immediately something's a little bit off with Eclipse. You'll see that it's complaining. And don't worry, if we hover over it and see why it's complaining, we'll see a message that says, this method must return a result of type int. And from what we've learned already, this message should make some sense, right? We defined this method to return an integer value, but we haven't done that anywhere. So Eclipse is kind of freaking out, right? Hey, you told me this method is going to return an int, but you haven't done that. You need to do that. So let's fix this. We want to return a value. And what do we want to return? Well, we just want to return x plus y. So that's what this return keyword does. It's a special thing for methods. It's basically saying, what is the result? So here, for my add method, the result is just x plus y. And now to use this method, we can test it out in over here, where we normally write our code. Notice, by the way, what I wrote, I'll put it into chat. This was outside of our main method. So before, everything that we've written, our code, has been inside of here. This is our first time that we're writing code outside of the main method. But to use it, we are going to go back to the main method. And that's because the main method is what's being run every time we hit the play button. So we need to write some code here. I'm going to create some variables. First equals 5, int second equals 8. And I'm going to say the result is add first, second. And then I'm just do system.out.print result. And if we run this, no big surprise, we see it's 13. And so what's going on here? Well, we defined our method. We defined what it does. So for any input x and input y, it returns the value x plus y. Here is where we actually use it. We actually pass in values, right? So here, when we defined it, we don't have values for x and y. X can be anything. Y can be anything, right? Well, as long as there are ints, any int, right? But here is where we actually tell the function, hey, run with these values for x and these values for y. So this is just me declaring some variables, but here is where we use our method. We call it by the name, and we pass in our parameters. So first corresponds to x, second corresponds to y, right? And again, first was 5, second was 8. So x is 5, y is 8. And then because this function returns something, we can store this value inside of another variable. And really quickly, can anyone tell me, how did I know that this result should be an integer? Right. Something in this file told me I have to put an int type here. How did I know that? If like I did Boolean, this would not work. And the fact that it underlines this should give a hint. How did I know this needs to be an int? Yep. Thank you, Sophia. Yep. I defined, oh, and thank you, Evan. Yeah, when I defined my method, I said that this returns an integer. And as a result, I have to store whatever I get back into an integer variable. One thing I want to mention here, though, is that I could have called this result integer. I could have had this return type as anything. I could have said this returns a double. Technically, I don't have to modify the body of the method because it can automatically convert x plus y into a double, but it can't do it here, right? So if I change this to say, hey, this returns a double, well, now I need to change result to be a double. And then I hit run, and you can see it's almost the same, but now it says 13.0, which shows that indeed this value is a double. It has a decimal point. And so, Jerry, I'm glad that you said that, but hopefully you see technically that's not true. Just because we pass in the integers for the parameters and the return value are separate. They're defined in different places. So you can have a function that takes in integers and returns a double. You can have a function that doesn't take in anything and returns a Boolean, right? You can do whatever you want. So really what's important is looking here. What is the return value? Right. Yeah. So I want to take a moment because I think this is an important point. I want to make sure everyone understands what we did here, what we did with defining a method and calling a method. This is really important because moving on, we're going to be writing a lot of methods ourselves. So I want to make sure I want to clear up any confusions about it as soon as possible. Does anyone have any questions about the code over here? Why we wrote what we did? Again, this part, you can ignore that for now, but everything else should make sense, hopefully. Why we have a double, why we have this index and y, and what the hell this return means. Right? By the way, I could have done something like int, or I guess double answer equals x plus y, and then return answer. Okay. So I can have multiple lines of code here. It didn't have to be one line. In general, your method can be as long as you want. You're going to have methods that are hundreds of lines of code long. And that's really the power of methods, because we can define it once And then we can use it multiple times, right? So maybe we want to do multiple results. So like we can add, I don't know, 4 and 6, right? We can add -8 and I don't know, 123, right? We can use our method multiple times. We just have to define it once. And again, what's the advantage of this? Well, if we find a bug, we just have to fix it in one place. We just have to fix it where we define our function. If we fix it here, well, every time we use it, now it's going to be fixed, right? Because they're all referencing the same place. So that's the basic workings of a method. We can write a couple more just to practice. So we can write the max function that was on the slides before. So public static, um, and let's do it with ints, max int x int y. And so I don't know if this is confusing, but notice that when you're defining methods, let's not even look at the stuff above. When you're defining methods, again, your parameters, they're kind of like fill in the blanks right now. You don't know exactly what x is going to be. You don't know what y is going to be. But that's the power of methods as well. It should be able to handle any possible value of x, any possible value of y. Right? You could have if statements like if x is less than 5, do this. If x is even, do another thing. You can do a bunch of things in methods. But that's again kind of a power. They're very flexible. But it can be a little bit confusing because again, you might be like, oh, okay, I have this variable x. What is x? You don't know at this point. X can be anything. Um, so here, when we define a max function, it might be a little bit confusing at first because you're like, well, okay, we have two variables, x and y. They can be anything. They could be 1 and 5. In that case, you want to return 5. But they could also be like 100 and -2. In that case, you want to return the 100. So the question is, how do I know which one is larger? If you remember from the slides, I didn't focus on it. There was some if statements, but maybe let's see if we can like come up with the logic um, ourselves. So I'm just gonna say we're going to need to do some sort of comparison, right? We want to figure out which one is larger. So let's do a comparison. X is less than y. Okay. So we do this comparison. If x is less than y, can anyone tell me what should go inside the body of the if statement? What should we do if x is less than y? Maybe, let's see. Someone I haven't heard from yet. Maybe Henry? Can you tell me, um, in this case, if we have two values, x and y, and we do this comparison in our if statement, if x is less than y, which one is going to be the larger value? Is it x or is it y? It's not a trick question, but maybe it sounds a little bit confusing. I'll write a comment here, maybe. So if we go inside the if statement, that means that the condition was true. That means x is less than y, right? We know that if we're inside the if statement. So this function should be returning the larger of the two values, the larger one. So what should we return? I don't know if anyone wants to help out. Okay, so Tyson, thank you. Y. Yep, that's exactly right. So in this case, if x is less than y, well, y is the larger one. So we want to return y, right? We could do another case. We could do like, or we can just do an else. So if x is not less than y, there's two possibilities. They're equal or x is larger. In either case, returning x is fine. Because if they're equal, it doesn't really matter which one we return. They're the same. And if x is greater, then we definitely want to return x. Another thing to show is that Java is smart, right? If we didn't have this else statement, you'll notice we still have the red underline. And that is because, well, it's the same issue that we saw before. However, it says the method must return a result of type int. And if you notice, like, we already have a return statement. So like, we're already returning something. So what's wrong? Well, again, Eclipse is smart. This return statement is only inside of an if statement. So only if x is less than y, we return something. If we just kept it like this, there are some cases where we don't have a return, right? If x is 10 and y is 2, well, we wouldn't go inside this if statement, and there's no return statement outside of it. So we need to make sure that no matter what happens, we always return an appropriate value. So here we put back that we had. And so we can play around with this. So instead, we can say the result should be a type int. So we do int result. We can do max of first and second. And if we run this, we can say it returns 8. Right. If we change around these values, let's do 15 and 8. Well, if we run this, we should see a different result. And indeed, we get 15 now, right? So it's actually doing the calculation as we run it. We can change the inputs and it will do something different, right? So if we change the inputs to this function, it will return a different result, right? So I'm just playing around with different inputs right now. So that's examples of two functions. I want to talk about one more thing in the time that we have left. And that's going to be a special thing called overloading a function. And this will be important for homework, actually. So we said that the method signature consists of the method name and the parameter list. We can have methods that share the same name, but have different parameter lists. So in that case, the signatures are still different because the signature is the combination of the name and the parameter list. We can have the same name if we have different parameter lists. When we have a case like this, it's called method overloading. What this essentially means is that we can have a bunch of different methods that all have the same name, but they're used in different ways. So here we have a method called myMethod, and we have kind of three different versions of it. One that takes in a single int and returns an int. We have one that takes in a float and returns a float. And we have one that takes in two doubles and returns a double. We don't know what they do. It doesn't really matter. But the important thing is that we can have multiple versions of a myMethod. Okay. And so if we look at our example, I want to write an overloaded max function. So I can do public static int max, and instead of 2 values, I'm going to take in 4 values. So here I define a max function that takes in 4 values, and it's still gonna return the max of the 4 values. Um, and in the interest of the time, I'll do it in a kind of a smart way. I'm gonna use actually my max with 2 inputs. So I'm gonna have some temporary results. So the first temporary result is, well, I want to know what's bigger between A and B. And then I have another result of C and D, right? So I have 4 values. I take the larger of the first two, I take the larger of the second two. And now I just uh, result. I just take the max of the 2 temporary values and return this. And now I can call max with 2 values and it works. But I can also call max with 4 values. So let's say 3, 5, -8, and I don't know, 43. And it will still work, right? And that's because I defined 2 different versions of it. One that takes in 2 values and returns an int, and one that takes in 4 values and returns an int. So this is called method overloading, where you have the same name, but different parameter lists. And it's useful because now you can have kind of extra behavior. You can have a max that works with 2 values. You can have a max that works with 4 values. All right. So that's the class. Sorry for going a couple minutes over. The homework will be posted as usual to Google Classroom along with the slides. And I'll actually try to post the code that I have today, both for the homework and also for what we did in class today with the example methods. So if you want to look at that, you can. If there's any questions, I'd be happy to answer them now. If you have to go, that's completely fine. I've covered everything I need to. So in that case, if you don't have any questions, I'll see you all next week.